Yeah. Good evening, students. Let's wait for others to join and then we'll start the session. We'll wait for some time for others to join. Okay, we'll wait for 2 more minutes. If others join, well and fine, or else we'll start. Today's agenda would be collection framework in Java. Today we'll be going in depth of collection. We'll see what is list, what is map, what is set, what is hash map, what is array list, what is linked list, everything. So if you are not aware of all these concepts in Java, today you will have it very clearly understood. Okay, so now let's start the session. So basically, collection in Java is a set of classes as well as interfaces that we use to solve problem. It has n number of use cases. So I, I do have a PDF document which illustrates almost everything that is needed for collection framework. We'll be going through it, and along that we'll be doing coding part as well, so that it's easy for us to understand things at a greater level. So now let's start. Those who have not joined, it's their choice. Still the attendance is only 54. So here we are into collections framework. So if I come here and show you the document from the start. So what is collection? If you want to know the definition, collections are used to perform operations such as searching, sorting, insertion, deletion, and manipulating data efficiently. The Java Collection Framework, JCF, is a set of classes and interfaces that implement commonly reusable collection data structures. So this is your entire chart. It's there on the display screen. So basically here you see, you have iterable interface at the top. Collection implements the iterable, and then you have list interface, queue interface, set interface. Map is separate, map is not a part of it, but map is used because it has key value pairs and it is used for a lot of DSA problems. So inside the list, you have array list class, linked list class, and vector and stack are your legacy classes. Legacy means they are not used nowadays very much, but then of course they are used whenever needed. These are basically old. They were introduced in previous versions of Java. They are not into very much use into modern versions. Again, you have queue interface. That priority queue is the class that implements the queue interface. You have DQ. DQ means double-ended queue. You have blocking queue, array blocking queue, linked blocking queue. Then you have set that has hash set. Set does not allow duplicates. Link hash set, sorted, and tree set. Again, you have map, hash map, link hash map. Hash table is a legacy class, tree map. So here you can see wherever you have dotted lines, that is implementation. Wherever you have solid line, that is a class extension, class extends. So just go through this for maybe 1 or 2 minutes, because on a higher level, list will have duplicates. It will have order of index. It will maintain the index. Queue, you can do insertion and deletion only on 1 or 2 ends. You cannot have in between. Set does not allow duplicates, and map is key value pairs. You can have one duplicate. You can have one null key and multiple null values. Set does not allow duplicates. Neither it allows null. And depending upon the type of the implementation that is there, hash set or link hash set, whichever we are using. So then we'll see the key features of collection framework. So anyone any doubts in this chart? If you want, you can take a screenshot of this chart. Any doubts in chart? Then we'll go with the details of this. Fine. So now key features of collection are they are dynamic in size, they are homogeneous, heterogeneous. They can store one type of data or multiple. For example, in map, you can have key value pairs. So you can have string as well as integers. Predefined methods are there. Time complexity versus space complexity. When you measure time complexity, measures speed, space complexity measures memory usage. So internal working, how it works, it counts how many operations run relative to input size n. For example, when the loop runs n time, you have O of n. When nested loop runs n into n, you have O of n square. And index access in array is O of 1 constant time. No matter you are using first index or 100th index, you will have O of 1, that is constant time. Time complexity cares only about growth, but not actual speed. So what is a list in Java? See, if you see a list, inside the list we have array list, linked list. Vectors are also used, they are thread safe. In multi-threading environment, we use vectors. But for now, we'll be working on array list and linked list. So what is a list in Java? So maybe in Java, you have array and array list, two types of things. Arrays are of fixed size. But when it comes to array list, that's of dynamic size. It can grow and shrink. So what is a list in Java? For example, you want to store elements like strings. Maybe you want to make list of groceries. So you have all these things, bread, milk, apple, eggs. So a list is an interface. Duplicate elements are allowed. Elements to be accessed by their index position. Insertion order to be preserved. So you can go with the index because insertion order is preserved. It is a part of java.util.package, and list implement classes array list, stack, vector, and linked list. Here you can see very clearly. So now let's try to make a list. Okay, why do we use list in Java? The answer is simple. To store multiple values in single variable, to add, remove, duplicate, update, or read elements, and it is dynamic, meaning it can grow or shrink in size, unlike arrays, because arrays are of fixed length and array list is dynamic size. So if you see the internal working, how it works, list is an interface, it's not a storage structure. Storage depends on the implementation. Array list uses dynamic array. Linked list uses doubly linked list, wherein you can add and or remove elements from both the ends. Vector is used for synchronized dynamic array. It is thread safe. In multi-threading environment, we use vector. And stack, like the plates that we stack, it uses a LIFO. That means last in, first out. So now, I want you to code this before I code. Make a list that is implementing array list and then add elements of your choice. Here you see the important part is you can get elements from the index. You can see duplicates are allowed. But then when we move to set, you will see that duplicates are not allowed. So I give you 2 minutes of time or maximum 3 to code this and see. And of course, you will have to import java.util.array list or list, both the things. This is the syntax. Please try to code this. And if there are any doubts, you can ask me. Then again, we'll be coding it together. And then this, we are using enhanced for loop to print everything from the list. You are free to add any item. Here we are just adding alphabets. You can add fruits, vegetables, maybe your movies, anything that you feel like. But if you are using string, make sure you put string values. If you are using integer, you need to put your integer values. Okay. Please start coding on this. Okay, so now for those who are able to do well and fine, for those who are not able to do, let's try to do it together. So here I open the IDE. Again, your collection framework is very strong foundation for DSA. If you want to do DSA in Java, you need to do collection frameworks for sure. So can I get in chat box, were you able to make a list? Yes or no? Can I get some responses in the chat box? Okay, at least. Yes, okay. Jatush says yes. Okay, fine. Srivali says, Prasad says yes. Okay, fine. The reason, because yesterday I asked and most of the students said yes, that we need to go. Again, when we make the set, you'll get an idea why we are using list and set. So now if I come here and yeah, XLRDSA. So in this, we are going to code a week 2, day 2. So a new package. Yeah. So I'll be making a new package in this. Week 2, day 2. So now here we come and make a package. Collections. So why am I making a package? Already a package is there. So I'll make a class directly. List example. Here we have. And then if you're doing it for the first time, it's fine. You can see the code, that is fine. We are here just to practice. So you can see list, then we use angular brackets. You can use string or any data type. Earlier, we need to write the same data type here, but in modern versions of Java, it was inferred that since you are using this data type, string, you don't need to write string here. So we are going to have a list of string of maybe fruits is equals to new array list. And then we need to import this too so that the error is solved. See, we imported it. This is done. We imported this. This is done. So now our variable is fruits. So maybe if I come here and tell fruits dot add and see, it will show inbuilt methods. Apple fruits dot add mango fruits dot add banana. And for SN fruit. So this one should print all the fruits. We get the fruits. And then we can print it directly as well. And then we use a get method as dot get, I believe, of fruits, sorry. And maybe I want to find the index 1 element. Since this one maintains the order of insertion, you'll get mango here. And let's try to print a line here so that we understand that after the line we are getting operations done. Yes, we get the line here. Good evening. Fine. So here we see. And then if I try to add one more fruit again with the name mango. Since it's list, it allows duplicate. Set does not allow duplicates. Maybe I'll try to write Apple only. We can replace elements also. There are a lot of inbuilt methods. See, we get duplicates here. And we can get the element on the basis of index. So it is allowed in list. Right? So when it comes to performance, we go complexity. For array list implementation, when you access by index, you have a constant time O of 1. Add at the end, you have O of 1 constant time. Add or remove in the middle, you have O of n because you traverse through the entire element. So this one takes some more time, and search is O of n. So when it comes to array list is resizable array, also called a dynamic array in Java. It is a class in the java.util package. Right now we are just doing list, but list and array list, they have very minor difference. Here you see we did list. We can do array list also instead of that. So it is a class in java.util package and implements the list interface. It works like an array, but the size can change automatically, increase when you add elements and decrease when you remove elements. Imagine a shopping bag that expands when you put more items inside, no fixed size, it grows as needed. This is how array list behaves. So array list implements the list interface. So array list maintains order of insertion, allows duplicate. Data is not synchronized, means it is not thread safe. In multi-threading environment, you cannot use it. Now, multi-threading is one of the core features of Java. So instead of list here, we can use array list as well. Here you can, it says that why are we using, okay, let's remove it. And again, it would be same. Internal working, it's more or less the same list and array list. Just minor differences are there. But for now, you can understand, okay, fine. So this one has taken the example of fruits only. And we can use system.out.print also. That is also fine. It will print all the fruit. So array list is a dynamic array internally. When the array becomes full, it creates a new bigger array and copies old items into new. So internally, it will copy old array into new array. Right? The reading item by index is very fast. Adding at the end is fast. Adding in the middle is slow. Shifting happens, and searching is medium speed. So basically, you can specify the size also, at what type of size you want the array list. So there are methods here. If I want to remove, I can remove the element also. We already saw get. We can remove either by name or by index, but then we should use index. See if I come here and tell fruits.remove. Fine. So if I give index, okay, at 0 index we have apple, we all know. So it will remove the 0th index of apple. And then now if the list is printed, there will be no apple. See. But then if I come here and tell remove apple, now the question arises is which apple we are going to target. This one is removing the first index, whatever it finds first, but it's always a better practice to go with the index. Maybe if I want to remove the third element, again, that is apple only. But then here you see we get apple in the beginning. So the index part we are accessing through the index part. If I comment this line, then we will have all the fruit elements. See, we have apple, mango, banana, and again apple. I don't want the apple at the last index, so I'll remove it. So these are some methods. Contains is there. This one returns a boolean. Clear will clear the list. So now in the same way, we have linked list as well. But linked list is a bit different than array list. So linked list is a class in Java that is used to store group of elements like an array, but is more flexible. It is part of java.util package. A linked list in Java is a collection where data is stored in small connected parts called nodes. Now nodes, when we'll come with the tree, we'll get into the greater details. Each node stores data and links address that connect it to the other node. This creates a chain-like structure in memory. Non-technical example, think of a chain of paper clips. Each clip is connected to the next one. If you want to remove or insert a clip, you just open that part. You don't need to move the whole chain. This is exactly how a linked lists work. Each node paper clip connects to the next and previous and is in doubly linked list. So you have, see this chart. This is quite important when it comes to linked list. You have reference to the previous node, reference to the next node, and the data field. The last one will always have null as the address for the next, and the first one will always have null as the address for the first one, because It is starting from index 0. So just go through this maybe for a minute or two, then we'll go with the linked list implementation. So this is how your linked list works. Again, when we'll be going with the tree data set and all, please make sure that you know this structure. You will have index, and of course, it will store address. It has basically three parts. First, the data. The previous part is the reference to one point, and the next part is the reference to the next point. Just like you have a train wherein you have different bogies or compartments in the same way. Pointing to the previous node, null indicates that there is no next element. You have element is the main target, but then it will have address also. If you want to remove one element, when you remove B, only A and C will get affected. From D to Z, if there are many elements, they are not affected. Array representation of linear double A linked list. So here we have double A linked list. If you have single linked list, only one node will be connected. Maybe A knows address of B, B knows address of C, C knows address of D, like that. Elements are stored as nodes, not in continuous memory. Each node has data that stores value, next address of next node, and previous address of previous node for double A linked list. For only double A linked list, we have this. It maintains insertion order, slower access but faster insertion and removal. So now here you see the same way you can make linked list as well. If you want, you can port this one as well. But this is linked list. It is not list or array list. Then we'll go with the next. We'll not be going with the vector one because we are not going to study thread safe and all, not into multi-threading or banking applications. But just we'll go through it. We'll not code it. If you want, you can code this one. So is it done? If done, please tell yes. Then we'll be going with the next because set does not allow duplicate. So here I want you to add some duplicate values so that you understand what is the difference between a linked list and a set, especially a list and a set. So these are some important methods. You can add first, add last, remove, get, size, and clear. Size will give you the total number of elements. So this is your big O notation. It's constant when it comes to removing or adding at the beginning. Just by searching, it's slow because it will traverse through everything. One pointer will point to another, another will point to another. So there is a difference between linked list versus array list. So in the real world, in messaging app, undo, redo, and music playlist, we use either linked list or array list depending upon the type of application. So now these are your linked list methods. Now singly linked list, doubly linked list will not be covering all this. Again, there are n number of things that are there. If we start coding all this, it's going to take few more days. So here you can see the reference is given. All you need to remember is linked list has a reference and data, two things. And array list has only the data because it's already sorted, it's indexed. So now vector classes. Vector classes are basically legacy classes or old ones. Like they are not into the modern version, but they are thread safe. As I said, the data is synchronized. At one time, only one data member can be accessed. Here you can see in array list, you can use multiple threads, but in vector, you use only one thread. Once your one thread is used, then you go with the another thread. One of the use cases example is your Tatkal booking for railway reservations, wherein your time is less, but you use vector database so that if one person is booking the tickets, only that person gets. Again, the timing is very fast these days. Modern days API and systems, they do transaction in milliseconds, not even in seconds. So we use vector for railway bookings and all. So the difference is quite simple. In vector, the data is synchronized, thread safe. It is slower as compared to array list. But in array list, one thing is good that it's the data is not synchronized, so it's faster one. But you cannot use it where you have multi-threading environment. Multiple resources are using your same data to do calculations on the database. So now let's come to stack. LIFO, pop push methods. That's it. So what is a stack? A stack is a linear data structure. We have already seen what is a linear data structure. Linear means inline. That follows LIFO, last in, first out. It means that the element is added last will be removed first. Stack is a class in java.util package. It extends the vector class, so it inherits all the vector features. It allows duplicates and maintains insertion order. Thread safe because it inherits vector, it is thread safe. So basically, stock has pop and push methods. Like we have stack of plates wherein the first plate that goes will be at the end and the last plate that goes will be on top. See, here also they are telling the same example wherein you have your pile of plates. So LIFO, again in DSA, it's very important. So you have pop and push methods. Push will add and pop will remove. So here you can see the key features are it's just peek. Peek is used to just see the element. It will not do any operation. And search returns the position of the element based on one index on -1 if it's not found. So here, since you have LIFO, the index is one based and not zero based, unlike your arrays. So these are your performance. And now let's try to use stack. See, stack is also an inbuilt thing. So let's try to use that and see. So we need to import it. And then we can put the items. So the moment we do food items dot, I believe it should show. Oh, no, we should do push, I guess. So without main method, this will not work. So we need to have a main method. So now I believe the code is a bit fixed. And now it should show us suggestion as well. Yeah, it's showing us. So now they are in stack. So they are one on top of the LIFO. If I try to run this, see, we get all the elements. If I just want to see which one is on the top, then of course I just need to do peek. Suppose we have a very big stack. Peek will just show you the topmost element. And see, we get the topmost element. If I comment this one will show you only the topmost element here. And then if I do a pop, pop will remove the topmost element. So now you should see only two elements at the last. See here. Since we did a pop, it has removed. First it's printing all the three. Then when we do peek, it shows the top element. And then I do pop. This one removes the top element. So anyone any doubts in this? Fine. So now these are the inbuilt commonly used methods. If I go for size, this one should print true because the size is true correct. If I try to print the boolean is empty, this one should still false. Since it's not empty. And then if I do, of course, search, I need to put a element. So maybe if I put an element that is there based on one index, it will give, maybe the answer would be 2 now. One index. -1 if it's not there. And then of course, it's there. It gives 2 index. From the backward, it's starting here. You can see this one is 1 index, this one is 2 index because it's a stack. So this is my first element when I peek, and this is my second element. Is this technical part understood? Why it's returning 1 and 2? Because it's just stacked. The last element is the first element, and the second last element is the second element. So now we are done with the stack as well. So now let's come with the set. Set does not allow duplicates. Okay, Pallavi. See, Pallavi, what happens is we are using stack. So basically, stack means you use LIFO operations. Okay, let me explain you again. See, when you're using stack, you're using LIFO operations, last in, first out, and it's one base index, not zero base index. Okay, so let me come here and push some more items. For items dot push. So this is my last element. Now this one becomes my last element. So whenever I do peek, I should see first thing is this element biryani. See, when I do this. So now if I want to search for biryani, since it has removed, yeah, if I have a search for idli, this one should give answer as 1 because it is one index. On top it's there 1. But if I search for dabili 1, 2, 3, this one will give third index. It will give answer here as 3. Just concentrate here, it will give 3. And then if I push the top element, it is 4. Because it's one index and not 0 index. What we are doing is we are now using stack. Stack means your data is structured like this. So you have first element, second element, third element, fourth element. It's not 0 index, it's 1 index. If you see here, yeah, returns position of the element from top 1 index or -1 if not found. Just read these lines carefully and you will get the answer. Is this clear now? One index from one index leap for approach, not 0 index. Last in, first out. Whatever goes last comes out first. Imagine you are putting things one on top of the other. So is this clear? First, everybody knows what is LIFO. Last in, first out. And then index is 1 and not 0. Index will be 1 based and not 0 based. So now here we come to the stack. Set, sorry. Set does not allow duplicates. Since we already have array list, why we need set for duplicates? So it is unique elements and elements are unordered, no guarantee of insertion unless using a link hash set. So if you use link hash set, only then you will get the data in the index format or else you will not get. So let's try to see that example. The golden rule is set is a collection that does not allow duplicate. If you don't use link hash set, even the order is not guaranteed. If you use link hash set, the order is guaranteed. So now Java will calculate the hash value and according to that. So we have already, because Java has another structures for duplicates, link, array list, list, array list, linked list. So set was created for some other purpose. So it will hash the data. It will see the hash code. If it's matching, it will not add. If it's not matching, it will add. So the golden rule is set is does not allow duplicates. Simple. So here we come. And if we use link hash set, then only we get the values, or else we don't get the values as well in the order. So now let's try to make a set example. Set.add is also possible, or you can use this also. So let's try to use it. Here we have, if I come in and do students.add, and maybe I should write this as small because students is not a class. And I'll have to use a main method. Again, I'm skipping main method again and again. Not a good practice. Students.add. And then maybe even I am a learner, I'll add my name, Moin. Here we come and see print. See, I added Moin Neha Abdul, but then you see the output came as Neha Moin Abdul. And again, if I try to add, my name again, here you see the important part. See, we don't have. So once you code practically, you will understand that set does not allow duplicates. If I do Moin 1 year, of course, now these are two different values. So it adds. But if I just do Moin, it does not add. I would like you all to code this once and see. Because from your DSA interview point of view, this is important. So please code this once and try to see it's not allowing duplicate, neither it's maintaining the order of insertion. When it comes to link hash set, at that time, your order of insertion is maintained. So the task for you is to first code this and use link hash set and see result. See, currently the order of insertion is not maintained, but it does not allow duplicates. So that's your task. Please try to do it. Please let me know when it's done. So when you change to link hash set, of course, the order of instead of hash set, we can make a link hash set also. Now the only difference would be first I need to import it. And now you'll see Moin, Neha, and Abdul. Of course, this also does not allow duplicates, but the order of insertion is maintained. But then if I use hash set, now there is no guarantee. See, so these are few little things that are important when you're doing data structures and algorithms. When you use hashing internally, hash set, link hash set, Java calculates the hash value. Hash set is a class that implements the set interface. It stores unique elements only. No duplicates allowed. Belongs to java.util package based on hash table. So example they have given for a student attendance register. If one student is present once, he is present only once. No duplicate element, no guarantee of order, allows one null value. Of course, null is, what is the difference between undefined and null? Anyone any idea? What is the difference between undefined? What is the difference between these two? This is a question that usually troubles freshers a lot. Exactly correct. See, to give you a non-technical example, suppose you are going from your home to your college. Today you have lecture for maybe some subject called project management, and you have a book called project management theory. So when you don't take that book in your bag, so if you do that by mistake, that is called undefined. And if you intentionally don't take that book, like, okay, fine, I'll not take the book, what will happen? So that is null. Null is basically when you do it intentionally. And undefined is basically happens, but it happens by more of a mistake type. You have not defined the value, you don't know. So null is a special data type that allows you to explicitly, means willingly, define the data as null that has no value. Is it understood? Which is intentionally. Yeah, that is correct. Krishna has written. When you do intentionally, it's null. Hope you understood what is null. Because null also plays a very important role. When you do it explicitly, you want to do it and you do it, that is null. And if you do it by mistake, that is undefined. So this is your time and space complexity. Then you have link hash sets. It maintains order of insertion we have seen, because hash set plus link list is equals to link hash set. Now here we have link hash set example. We have already seen that. No duplicates, maintain insertion order, allows only one null. So now let's come to tree. Tree is again your important concepts, tree and graph in non-linear data structures. Tree stores only unique elements like hash set, automatically sorts elements in natural order ascending. So this statement is quite important. Automatically sorts element in natural order. So your ascending order is automatically there. Again, you have tree traverser. We will be doing tree traverser tomorrow. So basically, it is based on red black tree, self-balancing tree. So the lower elements will go on top, higher elements will come on bottom. Stores only unique elements. Again, in tree, no duplicates are allowed. Sort elements in natural order, comparable or custom orders. So key features for tree are it does not allow duplicates, sorted order, backed by tree, does not allow null values, and it's not thread safe. So basically you have tree, and the best part is it stores the value in ascending order. Now if you want to sort data, that is numeric data, and you are given any, you will just put it in the tree and print it. Your job is done. I want you to do this code. If then we'll do it together. Put 6 to 7 values. It's just putting 10, 20, 30. Put some more values, 67, 78, 81. You will see two things. First, our duplicates. Plus data sorted. Those who don't know, see this is the basic for tree. Please code it if you find it hard going with the tree and graph problems in DSA. First, I would like you to code this one. This is very important statement. Again, putting in chat box so that you get an idea of it. Unique values plus sorted order always. Please code it. Then again, I'll be coding with you. I'm giving you time first to get familiarized with the syntax. Then we'll be doing it together. Okay, so now let's try to code it together. So numbers dot add. Maybe I'll put 45 first. So now you see we'll get 18, 24, 33, 45. See, the data is sorted. You know what all we can do when the data is sorted? We can go with the binary search instead of linear search. Instead of going through each and every element, you put the data in the tree set and then you can go with the binary search. Again, if I try to add some value that is duplicate, see now this is duplicate. We know it's duplicate, correct? See, it's not showing only. The moment I make it 19, of course it will show here. But if I keep it 18, it does not show. So is this understood? Again, the reason why I'm doing it because I know most of you are not aware of this concept. Maybe you are from different programming language or you are not from programming background. But then of course it's fine. There is always a start. From somewhere we need to start. So hope you are getting this. Thanks, Pallavi. Again, when we will be doing hard questions of DSA, you need to remember these rules. If I put something in tree, it should come in your mind automatically that the data will be sorted in ascending order. Duplicates will not be allowed because that's the work of tree set. Why not use array list? If I use just set, set means it does not allow duplicates, but it will not have data sorted. Tree set will have data sorted. So what is the purpose of tree set? It has unique value, sorted order, fast searching, automatically sorts plus no duplicates. If you want, you can note this point. Tree set's job is this simple. So maintain sorted, used a balanced binary search tree, no null allowed, throws exception. If we try to put null value, it should throw an exception. Say, let's see, nums dot add null. Let's see that also. It should throw an exception. And see, it's showing null pointer exception. It's not allowed. Now it works. Again, you have ceiling, floor, and all these methods. Ceiling means it will go to the top one. If you want, you can go through this. I have done already this coding before. So if you want, give me a marks that are 25 or more. So the next big thing that is there after 25, it will go with the ceiling part. If you want, you can do a bit of Google stuff as well. Or you can use just nums.ceiling. So if I come here and do ceiling, and then I want to find some number that is above 40. So it should print 45. See, it prints 45. If I put here 32, the next big number after 32 is 33. So it will print 33. Again with the floor, if I put here and try floor. So the small number after 32 is 24. So this one should print 24. But then if I encounter a number that is 30, so the answer would change, of course. This one should print now 30 here. Ceiling and floor, they are in math values. Ceiling means it will go with the top. Floor means will come to the bottom. Higher dot lower are there. So they are also using some mathematical operations that we do in DSA. So now poll first, take and remove the smallest number. So if you have some data set and you don't know, okay, with the poll first, let's keep this scenario in example, and then I'll give you a question. Poll first is your method for answer. So let's try to find. So basically, this is your question. I'll give you an array. So 47, 49, 48, 44, 40, 42, 38, 34, 39. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 36. So now this is your array, and I want you to return the students' marks. You are not allowed to use any sorting techniques of Java. Sorting or array comparison not allowed. Use inbuilt Java collection framework features. So these are the number of marks. Of course, the answer is here in front of you, but you need to do it and then give me the solution. Is the question understood, students? What is the question? You need to put it in tree set and do poll first. Is the question understood, students? Anyone any doubts in the question? Question is understood? Thank you, Pallavi. What about others? Please try to do it. Try to do it. If not, of course, I'll show you, but then you should be able to do it. Like the amount of content that we have covered, this should be an easy task for you. Yeah, Jatush, your approach is much better. So now I'm copying your approach only and I'm pasting it for others, those who have not done it. Again, like you don't need to use any if else, for loop, anything here. The question is pretty much given to you. So here, now the question specifically says that sorting or array comparison is not allowed. So hint is also given to you. So now here if I come and just write student marks, new class, students marks or students, I should write students marks, fine. And whatever Jatush has written, I'm just copy pasting it. There's not even a single line of code of mine here. Fine. So see we get, okay, 1 minute. Was 30 there in our list? In 1 minute. Run as. Okay, this one is not running as Java application only. Fine, 1 minute. We have marks, fine. Tree set is also there. Let's try to first write hi. Is this working or it's not working? I guess. No, this is 1 minute. Okay. There is a nested class, that's the reason. It should have a, okay, students marks. Let's do it. Okay, so now lowest marks. So now this one should print the lowest marks. And it says that integer lowest marks. Okay, it's mark, not marks. Student with lowest marks. Hope you got an idea of this. So this one, we are not using anything, just simple inbuilt features of Java. Yeah. Don't worry, Vivo. Ma'am will share the attendance link. It's not in my hands. The moment it comes, I'll give time everyone to write the attendance. So now here we come, and so here we have poll last. If you want the highest marks, of course, we just need to do poll last. And of course, highest marks. So I guess 49 should be the answer. So you see, it's quite possible to do things if you know the basics. So basically, tree sets instantly use a balanced binary search tree. So basically, see, this is very important. We'll be doing the tree travel cell tomorrow. So those who are here for attendance, don't pay attention. But those who are here for learning, please pay attention. So tree set internally uses a balanced binary search tree, red black tree. What we were talking about, RBT, balanced binary search tree. So what happens here is, just pay attention here. Okay, attendance please. Attendance is here. Students, take your time. I'm giving you 5 minutes to fill up the attendance. Okay, those who are telling attendance, take 5 minutes. Please fill it up. And after this, we'll be going with an important concept. At 8:35, I'll restart again. And this one is really important concept. Okay. So please make sure you fill up the attendance, and those who are willing, please pay extra attention. Others, those who feel like, okay, attendance is done, you will get certificate. It's up to you. I'll not force you. So now let's pay attention here how it works internally. Hope you have filled up the attendance sheet. So now see, first rule is tree does not allow duplicates. Fine. So duplicate value will not be there. So now how it balances left, right and all. So basically first you try to insert the 50, number 50. So it will be at the root. Root means at the top. Now it will see if the number is at the smaller than 50, then if new number is less than the correct node, it will go to the left. If new number is greater, then it will go to the right. Fine. If smaller, go left. If greater, go right. So that is the rule. Because tree is one thing that is more confusing to many new developers. Sir. So where we were here. See, we have root. So 50, 30, and if it is smaller, of course, it will go to the left. If it is greater, it will go to the right. Duplicates are not there only. It will ignore the duplicates. So the next item that we try to insert is 30. So 30 is smaller. Is 30 less than 50? Yeah, then it will go to left. Then we are trying to insert 70. So 70 is greater than 50. So it will go to the right. So now your tree structure is 50, 30, 70. Until here, is it clear, students? Again, I'll not be explaining it again and again. That's why this time I'm explaining it with full length. If we need, we can go with 2, 3, 4 times explanation. Right? Okay. If it is smaller, go left. If it is greater, go right. Duplicates are not allowed only. So you will not have any equal value. 50 will not be there only. Even if we try to insert 50, it will ignore. So now we try to insert 20. Now 20, is it less than 50? Of course, it is less than 50. So 20 is less than 50, then it will go to left. So again, here you see 50. So now this is binary search tree. It has only 2 leaves. So it will go, 20 will be at the left. Because 20, is it less than 50? Go left. Okay, fine. Then 20 is less than 30, go left. So 30 is fixed, but then 20 will be going left. Again, we try to insert 40. 40 is less than 50? Yes, of course. Then it will go to left. 40 is greater than 30? Yeah, then it will go to right. So that's how you will have your leaf nodes created. Is this until here, is it understood? How? So when we are trying to add new element again, this one will be the same rule. Left, smaller, go left, greater, go right. But then these two will be fixed nodes. Now again, what we are trying to enter, we are going to enter 60. So 60, here you see, it's greater than 50. Yeah, then you go to right. 60 will go right. So this one will go here. Now 60 is less than 70. Yes, so it should go to the left. If it is less, go left. It is greater, go right. Simple. First rule. Fine. So now, again, the last element that we are going to insert is 80. Again, 50 is greater than 80, go right. 50 is greater than 70, go right. So this is how your tree will be formed. First 2 elements will be either left or right. You will never have same number of elements for sure, because duplicates are not allowed. Then again, 30, of course, 50, it's less of yes. So you will have branches wherein you can go for to the left, you are very sure you will have smaller values. You can go to the right, you will have greater values. Again, once you see this element, the elements left to this will be smaller, the elements right to this will be greater. So this is your parent, and these are your child or leaf nodes. And this is a branch, because one branch is having 2 more leaves. So this is your binary tree wherein you will have only 2 leaves of one parent. That's it. Again, if some number was there, there was 11 and there was maybe 22. So 11 will go to left of 20 and 22 will come right to of 22. 22 will come right to 22. Then you can have it more complex as well. So this, again, if somebody wants an explanation, please ask right now. Tomorrow when we go with tree traversal and all, I'll not be completing this again. So if there are any doubts, feel free to ask me right now. It's okay. If you ask me 2 times, 3 times, 4 times, please ask. For attendance and all, please see the chat box. I already gave 5 minutes. Okay, thank you, dear. Please ask me for the content related doubt. For attendance, of course, the chat box is there. Go to the chat box. Ma'am has already sent the chat link, and I'll give you every day 5 minutes of time for attendance. Okay. Between 8:30 to 8:35, there will be attendance link shared by Sushmita ma'am, and we'll be waiting for that. Okay. So to add elements, O log n, removal, O log n, and travel set O of n. We are going to entire not as fast as hash set. So of course tree set. So these are your key differences. Hash set has no order, link hash set, insertion order, tree set sorted, array list allows duplicate plus order, tree set unique plus sorted. And maybe I'll give you a screenshot of this. If you want, you can save it in your systems. It's going to be useful for everyone. Those who are looking for DSA in Java. One image is sent to you. Save it if you want. Again, you have some inbuilt methods, and that is fine. We'll see later on. Now you have queue. You have single-ended queue, double-ended queue, just like you have queue. So now we are into queue data structure. So what is a queue? A queue is a linear data structure used to store elements in order. One request, students, for attendance, please don't ask me. For attendance, I'm telling you, ma'am will share the link every day. Don't ask me in personal chat for attendance. Again, I'm sharing you the link. Those who are attendance ready people, please make sure that at 8:30 ma'am sends the link. Between 8:25 to 8:35 attendance will be taken. Don't join at 8:40, 8:45 and ask for attendance link, please. It's a request. I don't want to name anyone, but please don't do it. A queue is a linear data structure used to store elements in order. So basically, you have array queue, linked list, and priority queue. These are the implementations. It maintains FIFO, first in, first out, add or offer. We use offer because offer is safe. Add will return an exception. Here you can see. For remove, we use poll because if null elements are there, then it's better to go with the offer. Offer will return false, whereas if you have nothing, you try to do an add, it will throw an exception. So this is the queue interface. So if you want, you can code it. So queue follows FIFO, first in, first out. Like you have your railway tickets, or maybe when you are paying fees, you are standing in the queue. So you first one that enters will be the first person to exit. You have a single-ended queue. When you have double-ended queue, of course, that's D queue. If you want, you can code till here and see peak and poll, all these things. So here you can see, if you try to use this, when you use queue, internally linked list will be following the queue structure, wherein you can do poll and peek. These features are not available in linked list if you use list here. So how linked list implements queue? Now linked list is a doubly linked list internally. Each element has previous data, of course, previous one, the data, and next one. So these are the two pointers. If you are from C++, you might be knowing pointers. If not, you can just store this as a reference variable, or they give a reference to the previous and next data. So head node is in the front and tail node is in the rear. So when you do offer, of course, you are going to get ABC as answer because you are adding it. Oops, it should not be the case. So in the real world use case, of course, you have add, offer. Offer is safe because it returns false. It will not throw null. You have remove or poll and peek. So queue follows FIFO, stack follows LIFO. Queue removes first, stack removes last. It is used for task, it is used for undo operations. So priority queue, PQ. Again, priority queue is something, is a special type of queue that is given priority to the smallest element by default. It does not work on FIFO, it works on priority. So again, when you use PQ, you give priority to something that is smallest. For example, when we were in school, arranging students in the morning for assembly and prayers by height was some example of priority queue. The person with the shortest height will be at the front and the person with the biggest height will be at the last. So maybe imagine students standing in a line for medicine. Who gets medicine? The student with highest fever, not the one who came first. Priority queue basically. So here you see again, order not guaranteed, but when you do poll, you will get smallest figure, and then when you do peak, you will get the next smallest figure. Of course, the order is not guaranteed, but the moment you do poll, you will get for sure the smallest number. If you want, you can code it and see. If not, that's fine. Just remember it, because we will not be investing a lot of time on collections. From tomorrow again, we'll be starting with DSA. But most of you were having some doubts in DSA, so that's the reason we started with the collection framework. Automatically arranges elements by priority. Smallest becomes the head default. So these are the small values climb up, big values fall down. Simple rule. Priority queue always works. Small value will be up, big value will be down. So now you can see, in case of priority queue, this happens. 5 will go up, again it will go up, and it will be on top now. So here you see, number bigger than 5 will be at left. Of course, the numbers that are bigger, they'll be below, but then of course, you have two branches. But here you see, if you try to add 30, 10, 20, and 5, so 30 will be there, then 10 will go up, 30 will be down, 20, because they have two branches. Then 5 is there, 5 is less than 30, it will go up, 5 is less than 10, it will go up. Priority internally stores this heap in index form. So index 0 will be 5 value, index 1 will be 10 value, index 2 will be 20, and index 3 will be 30. In your heap memory, you will have this form of representation. The rule is very simple for priority queue. Smallest element at 0 index, bubble up, bubble down. If this one is smaller, the next number, it will go up. Smallest one will be on top always. Okay, this was the example, bubble up and bubble down. You keep on swapping internally. Java DQ, FIFO first in, first out, and LIFO last in, first out. So what is DQ in Java? DQ stands for double-ended queue. It is a linear data structure that allows insertion and deletion from both the ends, front and rear end. It is called DQ or DEC. So basically, when you are in the bus, maybe in local buses, you have two doors. You can enter from both and exit from both. So that is an example of your DQ, double-ended queue. Even in the trains, you have two doors. When you are catching a train, you have two doors. So you can either enter from any of the door or exit from any of the door. Allows insertion deletion at both front and rear. Can act as LIFO and queue. FIFO can be implemented using array queue or linked list. So you have stack. In stack, you have only LIFO, last in, first out. Queue, you have first in, first out, and DQ, you have both the ends. So please understand the difference between stack queue and DQ. Stack queue. Stack and queue can be more of the same, but DQ is something different. And again, priority queue will give priority to the smallest one. So now here we have the DQ example. So now doubly linked list is also there. Map collection. Map is key value pairs. Map is going to be our last thing for the day. And then of course, we are going to wind up. So map is not a part of collection framework, but it is included in collection framework. It is used to store key value pairs. So it has hash map, link hash map, tree map, hash table. This is legacy. A map is a collection in Java that stores data in key value pairs. Each key is unique and every key points to one value. Like you have dictionary, you have key value pairs. So student ID, student name, you have here you can use strings, or maybe you can be homogeneous or heterogeneous. You can have only one data type or you can have multiple data types. Maybe a string and an integer. So basically hash map uses hashing buckets, hash code plus keys. So hash map average time is constant, you can see. But for tree map is O log n. Because of tree, it will travel through every element. So this is an example. We'll be using this example just once. And then of course, this is the last code that we'll be doing. So it allows multiple null values, but only one null key. We'll see that also. And let's try to have a number and string, roll number and names. Map has key value pairs. Map has a put method. So here we come and we see students. If I try to insert a duplicate value, it will not allow. Duplicate keys are not allowed. Duplicate values are allowed. So now if I come here and do 103 again and then put Madhav, this one will not be allowed. Only 103 can be once. Madhav has replaced. But then if I put it 104 or 105 maybe, now this is allowed. And see, it's sorting the data along with the keys. Although we have 101, 105, 103 and 104, this one is printing 101, 103, 104, 105. So now these are the, again, I can have one null key and multiple null values. For example, if I come here and put students dot put and one null key, if I put Abhay, I believe since it's hash map, it allows. But then if I have multiple null keys, this one will not put. Maybe I have a demo name. This one will not allow. It will print only Abhay. But I can have multiple null values. For example, if I have here 109 and then multiple null values are allowed, but only one null key is allowed. See, I have multiple null values, they are allowed, but null key only once is allowed. So now put, get, remove, contents, these are all the methods. Key value pairs are there. We can update any one thing. If I do map.put, or maybe we have find method and all, boolean, hash key, all these things are there. So hash map in Java. Hash map keys must be unique, value can be duplicated. We have already seen it. See, we have hash map only. Keys must be unique, values can be duplicated. Doing a hash technique internally does not maintain any order, neither insertion nor sorted. Allows some null key and multiple null values. One null key. So here we have it. Fine. So now here we have hash table. Again, this is implementing. It's a synchronized one. So thread safe, it is legacy one. So basically multi-threading for this, you need to have hash table. So what is tree map? Again, tree map is Java's collection framework. So it's balancing tree only. It does not allow duplicates. So again, tree map, you will have values can be null. Tree map cannot compare null values. And here tree, as you know, the data will be sorted. Again, the tree map working here, you can see. So I believe now comparable and comparators, they are not very much into like use when it comes to DSA. Of course, we use inbuilt methods like we did yesterday, but then these are the questions if you want to do. Comparator in Java, comparable, Java 8 collection features and all. So I believe that's it. We are done with this. So hopefully I'll send this to ma'am if needed. Attendance link is already shared. So anyone is having any doubts, you can please feel free to ask me. Again, you want this notes, don't worry. I'll share it with ma'am, and then of course ma'am can send it to all of you. What you are not able to open? If you are not able to open Siley ma'am, 1 minute. Then also you'll have to ask ma'am only. See, this is the attendance link that I have got. I've shared it in the chat box with you. I guess I'll share it with ma'am, and you can find it in LMS. In case if you are not able to find ma'am, then I'll push it on GitHub. Okay. First, try to contact ma'am. I'm pretty sure she will share it with everyone. If she does not, of course, I'll push it on GitHub. So you'll get it from GitHub. Okay. I'll push this one on GitHub. I don't have any point of keeping this with me. It's good for you if you want to practice. I'll push this one on GitHub also. Okay. Don't worry. It is 62 pages. So anyone, any doubts in any of the concepts, students? If there are doubts, please feel free to ask. Or else tomorrow we'll be doing tree travel cell. What is your pre-order, post-order? But first make sure that today you have understood tree. It will sort data automatically. It has leaf node and all. GitHub link, of course. GitHub link was shared, I guess, yesterday with everyone. Again, I have not shared this node. What we did on week 1, I shared that GitHub link. So if somebody wants GitHub link, I'm not really remembering it, but then of course I shared it yesterday with students. Again, I'll upload this one and send it to you next week for sure. If I come here and do Java, yeah, Java link one. This is the code of day 1. Okay. If somebody wants, we have it in the chat box. Okay. So you can see the host who's there in the meeting. Again, you have a number also on the joining link that you had. and I'll share with you. Don't worry, on GitHub also if needed. So if there are any doubts, feel free to ask, or else we can end the session. Anyone, any doubts? Okay, dear. Fine. Thank you. See you all tomorrow. Thank you, everyone. Okay.
Yes, sir. Thank you so much.
Thank you, ma'am. Sure.
Yeah, thank you. Have a good night.